Now we will take a look at the traversal of a linked structure. We have a collection of points stored in a linked structure. Now the traversal means we will print out all the points in this linked structure. Here we still use the point class and node type structs defined in the last video. We have a linked structure and we store the point in this linked structure. We have many nodes in this linked structure, and this is the last node. Head is a pointer pointing to the first node of the linked structure. Okay, to traverse this linked structure, we need another pointer, current. This means current. When we print the point in this linked structure, we move the current, this pointer. We print the data in this node and move to the next node. Print the data, move to the next node. We always move the pointer current. We don't move the head, this pointer. So if we move the head pointer, what happened? So we move the head, print all the points in this linked structure, and then we move the head to the end of the linked structure, assuming head is here. Now what happened? We lost the address of first node. That means we lost the entire linked structure. So we always need to keep the head pointing to the first node. We don't move head. And lost the entire linked structure is not what we want. We print the points and lost the entire linked structure. It's not what we want. So we keep the head here, point to the first node, and we move the current. The current, okay, the current, its initial value is head. So that means this is the current. The current, its initial value is head. It points to the first node of the linked structure. And then we have the while loop. While the current is not null pointer, and we print the data and move the current. So this means we will move the current if we're not at the end of the linked structure. If we're not at the end of the linked structure, we will print out the data. And the current point to a node. In this node, we have data and next. So we print out data. This data is a point. So in the point class, we overload the output operator. So that in the point class, we overload the output operator as a friend function. Now we can use the cout output operator to print the point object. This is the point object. Now when the current point to the first node, the current data is 1, 1. Is 1, 1. And then current equal to current next means we move the current to the next node. And now the current pointed to the next node. Now we're not at the end of the link structure. So if this while loop condition is false, we print out 2, and then move current to the next node. And then we're not at the end of the link structure. So print the data 3.33 and then move current to next node. So here we use a for loop, we use a while loop to move current pointer from one node to next node to next node until we reach the end of the linked structure. Now we're at the end of the link structure. Current is here. Current point to the node contain 9. And now the current is not null pointer because current store the address of last node. So this condition, the while loop condition is true. It's true. And then we go inside the while loop. Go inside the while loop, we print out the data. The data is 9. And then the current equal to current next. Now the current pointed to the last node. Its next is null pointer. Now we update the current is null pointer. Null pointer. And then go back to the while loop. Current is not null pointer. Now this condition is false. This condition is false. We will exit the while loop. Now the current is, we update the current. Current is null pointer. Null pointer. We exit the while loop. We complete the printing all the points in the link structure. Okay, now let's take a look at the search. We want to search a point in a linked structure. Now we want to search the point this. It's X is A and Y is B. We call this the target point. So we have a head pointer always points to the first node of the link structure. And here we also need another pointer, current. So this search a point in a link structure is very similar to the traverse link structure. But here we add another condition. So we still use a while loop, and the current initial value is head. Current point to the first node of the link structure. And then we have the while loop. The while loop. The while loop, while we're not at the end of the link structure. And we add another condition. Here we have two conditions for the while loop. This is a not, and we're not at the end of the link structure. And we don't find the matched point. So not match. Here are two conditions. We're not at the end of the link structure, and we don't find the matched point in the link structure. And then we move the current. We move current to next node. Current equal to current next. Now after we complete so if we exit a while loop, what does it mean? Now if we exit the while loop, that means we're at the end of the link structure. This implies we don't find the this implies we don't find the matched point. So now, if we have this condition, we are at the end of link structure. That means we don't find the matched point in the link structure. And now another thing is that now we are not at the end, and we are not at the end of link structure, not end. So this also means we find the matched point. So in these two conditions, we will exit the while loop. So now after the while loop, we will check which conditions, which situations we are in. So if we are at the end of the link structure, means the current is no pointer. So that means we don't find the matched point in the link structure. We will print the message and the target point is not in the link structure. So else means the current is not equal to null pointer. So that means this condition is true, but we exit the while loop. This means the second condition not match. This condition is false. That means the not match is false means we find the matched point. So we will print out else if we're not at the end of link structure. We find the matched point. We can print this information. We can implement the search function, and its return type can be bool or a pointer. Okay, so we can implement the search function as this. The return type is bool, search, and point p. Okay, I will add the const here. Pass by reference and const. So if the current equal to null pointer, and return false, else return true. So we can implement the search function. Return type is bool, and we have this function. Or we also can implement search function, let it return a pointer. Return a pointer. The node type star. And here we will stop here, and after the while loop we just return CUR, return current. So and then if the search return a null pointer, that means this target point is not in the link structure. So if the current return pointer current is not a null pointer, means we find the target point, and the current point is pointing the node contain the target point. Okay, this is a search operation, search and traversal operation.